Hello students, in this session let us know about the classification of elementary particles. So these elementary particles, they are mainly classified into two categories. Broadly they are classified as either quanta forces or matter particles. Matter particles are classified into the following two categories: leptons and hadrons. The hadron family further consists of baryons and mesons. So if we see the classification of the elementary particles, they are either matter particles or quanta forces. So quanta forces consists of the particles which are the field particles of different kinds of interactions: photons, WZ bosons, gluons and gravitons. And matter particles are hadrons, and these hadrons are further classified as either mesons or baryons. And these two are made up of again the fundamental particles called as quarks, and another kinds of matter particles are leptons. So quanta of forces. So corresponding to four different interactions: strong, weak, electromagnetic and gravitational, there are certain quanta of the forces which act as the mediator of these interactions. They are gluons, W and Z bosons, photons and gravitons. This table shows the properties of all these kinds of quanta of forces. Now, matter particles. Leptons do not participate in the strong interactions. Neutral leptons participate only in weak interactions, whereas the charged leptons participate in electromagnetic as well as in the weak interactions. And it is observed that hadrons participate in all kinds of interactions, and all the hadrons having size of the order of femtometer are in fact composed of quarks and antiquarks. So these are the properties of the hadrons, charged leptons and neutral leptons. Now let us know in detail about the antiparticles. Scientific history of antiparticles, or sometimes it is also called as an antimatter, started in 1928 when Nobel laureate physicist Dirac dramatically predicted on theoretical basis the existence of a particle that in certain respects was similar and in other respects a direct contrast with an electron. Dirac constructed a relativistic equation now known as the Dirac equation, which has four solutions. The first two solutions were used to describe the electron. The last two solutions having negative energies were interpreted as antiparticle to the electron. And in 1932, Carl Anderson observed this antiparticle in a cloud chamber, that is experimentally. Later, it was named as positron, which has the same mass as that of the electron but opposite charge. In later experiments, pi ions and mu ions were found to come with both particles and antiparticle species. In 1957, CPT theorem, that is charge conjugation, parity and time reversal theorem, was formulated, which enunciates that for every particle that exists in nature, there is a corresponding antiparticle. The theorem also predicts that the antiparticle has the same mass as its particle, the same lifetime if the particle is not stable, the opposite charge and the opposite of all other internal quantum numbers. Certain particles act as their own antiparticles, such as photon and pi zero. So students, what we have learnt in this class? We have learnt about the classification of the elementary particles and particles and their antiparticles. Thank you.